Thank you so much for everyone joining. It's wonderful for us as the IPC Education Foundation to bring webinars and information about the electronics manufacturing industry to everyone interested to learn more about opportunities. And today we are extremely thankful to have representatives from CASE here to share information about themselves, who they are, where they fit into the industry, as well as the career opportunities associated with internships, co-ops, etc. They will also be introducing themselves, provide not only an overview, but also share some personal stories of themselves. So please have a pen and a notepad ready to take notes. And then, as I mentioned, there will be a Q&A session afterwards. So thank you so much to CASE for their wonderful support. They are a great partner to the foundation and sponsored the career panel roundtable discussion at the IPC Apex Expo STEM outreach event that we hosted end of January in San Diego. So thank you so much, CASE, for your support. Great. So here we go. Panelist, please introduce yourself.
So I guess I'm on the left, so I will go first. My name is Deborah West. I'm one of the HR business partners that works for the Integrated Defense Solutions Division of CASE, and that is located outside of Philadelphia. And so I have been with the company for 7 years, but I have been working in HR for over 40 years. So I won't say how many, over 40, but the reason that I think I'm here today is that I manage the intern and co-op programs here at the Lansdale site. We have some good relationships with some of the schools that are in this area, and I have an interest in growing that program here. So I'm anxious to be able to talk to everyone.
My name is Robert Soto. I'm here at CASE in San Diego. So I represent the manufacturing operations down here. I've been with CASE about 5 years now, almost 5 years. I started as a value stream manager in production. I've been focusing the last couple of years on our training department, our manufacturing training department. My background goes into, I started out as a mechanical engineer. I've been a licensed mechanical engineer for over 30 years. I did a number of years as a design engineer. I got into operations then. So then I became manufacturing and quality assurance and various roles associated with producing hardware in production area. Over the last 15 to 20 years, though, I've been focusing on manufacturing operations. So I've been a value stream manager, manufacturing operations manager, and that's how I came into CASE here in San Diego as one of the operations value stream managers. And as I mentioned, I'm focusing now on our training department for our production operators. Thank you.
So hi, everybody. Good afternoon. My name is Jason Fullerton. I am a principal manufacturing engineer here at the CASE facility in Lansdale, Pennsylvania with Deb West. I'm a degree manufacturing engineer. I've been in the electronics industry since 1993, so I'm approaching about 30 years of doing this. My expertise and specialty is in soldering and assembly of printed circuit boards and electronic assemblies. I've been with CASE for about 5 months or so, and I'm going to talk to you today when we get to that section a little bit about my experience as a co-op in a co-op program and how it helped me kind of direct my career in the engineering field.
So CASE is a company that works on different types of critical systems that both protect and enhance the lives of individuals around the world. We specialize in microwave electronics, antenna subsystems for electronic warfare, radar, tactical munitions, communications, navigation, and identification missions. So some of the specialties that we work in are radar, data link systems, electronic warfare, microwave, military antennas, missile products, radar technology, and satellite waveguides. Okay, you can move to the next screen. Jason,
Okay.
did you want to go over this? Because I think this is all part of your presentation, is that correct?
Well, I was prepared to talk about this. I think Andrea had marked me, but if Jason wants to take it, that's fine.
No, it's all you, Robert.
Robert.
Go right ahead,
Go,
Robert. It's all you.
go
So
down.
this describes how CASE fits into the military defense electronics industry. So we call our business defense electronics. We make electronics associated with the military items. We're not necessarily a direct supplier to the military. This kind of shows a tiered structure. So the tier one is going to be more like the prime contractors that supply the aircraft, the ships to the military. That might be like the Northrop Grumman's and Lockheed Martin's and some of those bigger companies. So CASE falls into the levels, the tiers 2, 3, and 4, which are suppliers to those tier 1 contractors. So as a tier 2 contractor, CASE can supply some of the major systems that go on the aircraft. Some of those things that, as Deb had talked about, they fall into radar. We've got forward and aft radar detectors. We've got targeting and ranging systems, so they actually identify the targets and can find the range associated to it. So our electronics will analyze those things and calculate and figure out where that is. We've also got signal jammer devices that can actually jam some of the competition's, the enemy's signals and stuff. At San Diego, we focus more on the tier 3 and tier 4 areas. So the tier 3 is where we're going to supply electronic sub-assemblies that go into those major assemblies. So all of our sub-assemblies, they do functions. They're function-oriented. They do a specific thing that fits into the tier 2 sub-assembly. So some of the things we do here in San Diego are signal detectors, signal amplifiers. We find the signal in the air, and our electronics devices will detect that, and then we'll amplify it and give a stronger signal. And then we actually will even send that back out and we have some signal jamming devices so that the enemy's signals will be all messed up and they can't really detect our stuff that's going on. Frequency synthesizers that, once again, it has to do with the microwave signals going in, and we mimic the microwave signals that are out in the air, and we do stuff with that. Then the tier 4 CASE is also involved in the tier 4, which is more at the component level. So in San Diego, we do some of the tier 4 and then tier 3. The tier 4s, we also get from our other CASE suppliers, maybe in Denver and other sites, the tier 4 components, filter assemblies. We make small little filter assemblies that are, 1 inch or something or less in size, and they go into bigger, higher level assemblies. Filter assemblies, voltage regulators, some of those signal amplifiers. So you can see in that picture there, some of those components, they're stamped with the COBM, the CASE name on it, and those can be sold to various entities, but those go up to higher level CASE products and build in the higher level assemblies. So once again, that all fits into the defense electronics industry, and we generally fall into the tier 2, 3, and 4 levels of that.
Deb, you had this slide on the one that was coming.
Okay, so this gives you an idea as to the various locations that CASE is located across the United States. We have a large group that is in the East Atlantic. Our headquarters is in Arlington, Virginia, and we have offices, major offices in Exeter, New Hampshire, Lansdale, Pennsylvania, San Jose, San Diego, Colorado Springs. Now, the IDS office that is represented here today has, which is San Diego and Lansdale, also has a couple sub-offices, Tijuana, Richardson, Texas, Forsyth, Missouri, Eatontown, New Jersey, and Clearwater, Florida. So we represent a good chunk of this organization, and we're pretty scattered. Oh, I forgot about Sweden, too. So we're also in Sweden as well. So it gives you some understanding as to, where we're located. Okay, next slide. So this division here, Integrated Defense Systems, is, I think, as we said, we have about 1,800 and plus employees. And we went over, you know, the various areas that we were in. We have 15 plus customers across many different defense markets. And again, as we said, we specialize in the electronic warfare, the radar, the missiles, any type of communication, navigation, and identification, so CNIs. So they'll give you some ideas the various markets we work in. The two other divisions, space systems and missile systems, work on some other areas, but gives you some understanding as to how across CASE we cover various different sectors.
All right, looks like it's time for me to talk about myself a little bit. So what we're seeing here, I'm going to talk about my experience as an engineering co-op during my undergraduate education. So I am a graduate of Kettering University. At the time, it was called GMI Engineering Management Institute. It's located in Flint, Michigan. It is a co-op engineering undergraduate program. And one of the things I was looking for specifically, I was looking for a university experience that required co-op. So at my school, first-year students are eligible for and expected to co-op. Co-op has a minimum graduating requirement, so you cannot graduate from Kettering University without fulfilling some requirements for mandatory work experience within the program. So this is a case where it's not an optional program, but it's actually mandatory and fully integrated into the university experience. That was one thing that I found when I was looking for universities as a high school senior, was that some schools have a program that you have to apply to, and a small select group of people get involved in it. At GMI or Kettering, 100% of the students are involved in the co-op programs. It's got a very strong, long history as a co-op engineering institution. In addition, my school also requires an undergraduate thesis project from all of their graduates. In most cases, that project is a combined project between both the academic aspect of your university career and the practical aspect with your co-op employer. So in those cases, the students are required to put together a proposal that's approved by and managed by both an advisor at work and an advisor at school as a requirement for graduation. So, and that's in the 5th year of that program. Kettering is a 5-year intentional program. So if the 5th year is an extra, it's graduating quickly if you make it through that in 4. That school works on a quarterly basis. So that school works through 12-week sessions over the course of the calendar, rotating between school and work every 12 weeks. So when I was in undergraduate, I co-opted for a total of 9 12-week work sessions at the Ford Electronics, or now Visteon facility here in Lansdale, Pennsylvania, actually. So I graduated from college with 108 weeks of actual practical work experience before I even received my bachelor's degree. Now, the topic of our presentation today is, how do you land an internship? How do you land a co-op? And, you know, I've been doing this for a little while. In the 1990s, networking was a little different than it is today. So what I did when I got to school, I didn't have a co-op sponsor when I first arrived as a freshman. So I went to my corporate relations department at the school and asked them, how can I help you get me into a co-op position? So they provided me a contact within our alumni relations department that gave me an alumni directory that I went through, and I typed up letters and sent copies of my resume to various GMI Kettering alumni that were in the area working with an industry, basically saying, I'm a freshman, I'm at GMI, I'm looking to acquire co-op sponsorship. If you know of anybody, please forward my resume. But one of those alumni had just graduated within about 2 years, and he was working at Ford Electronics Visteon facility. Took my resume, walked it down to human resources, gave it to the business partner that managed the co-op program, and they worked together with the school to facilitate the interview and get me placed. And I managed to win the placement and work for the company during my undergraduate experience. Now, that said, though, if I sit here and give you that advice, you would think I was old, because I am a little bit, but that's not how you network nowadays. It's different in the modern times. But there is just the modern version of the same thing I described there. Oops, one slide too many, sorry about that. So there's a number of different ways you can network in the modern world that are available to you. One of them is, like I described, go to your university. I mean, if your university has a co-op program, they very likely have staff there that are responsible for assisting their students in acquiring co-op placements. So start there, find out what they need from you, how you can help, be involved and be an active participant in that process. You can also go on social networking and look for alumni of your college that may be local to you working in a desired industry. LinkedIn is a really great resource for professional networking. It's actually how I found the position here at Case last year when I was looking for a new position. Facebook as well. So I'm sure that the people on this on the other end of this presentation are more savvy than I am with social networking. But that's a really good way to make contacts and try to reach out to put yourself out there to find maybe someone that could help hook you up with an organization looking for co-op students. Another really good way to get involved in industries is to look for student chapters at your school or at local universities of professional organizations. The IPC has a number of student chapters with different schools. SMTA is another organization that works in the electronics field. There's a Society of Manufacturing Engineers. And there are a number of different professional organizations in different kinds of industries that interact with students at the university level and also have professionals that are in practice in those industries as well that are involved. So that may be another way to find a networking contact within a company looking for co-ops. Job fairs kind of went away during COVID for the most part, but I remember when I interviewed with Deb last year, she was at a job fair last August and had to call remote to perform an interview. So we're engaging in that way as well with the different schools that we work with. So that's a good way if your school hosts those. And another way to do it is to, if you know companies in your area that you desire to interact with or to look for opportunities with, go on their website, go on their social network, see if they have information about their co-op or internship program that you can directly apply to. It's another good way to feel out the opportunities that are available to you locally. One of the things I'll say is you want to be an active participant in that sort of activities, because when the employers see that you're taking an active role in trying to get yourself placed, that automatically gives you a good view in their eyes that you are very engaged in trying to direct your career actively rather than sitting back and waiting for the world to come to you. So that definitely reflects positively on you when you do those sorts of things. So I talked about how I got my co-op sponsorship at Ford Electronics back in the 90s. So I want to talk a little bit about some of the benefits of being involved in an engineering co-op program. Now, co-op can be found in different degrees besides just engineering, but I'll talk about my experiences personally. And I'm going to highlight three major benefits that I think are really important for the people on this webinar to understand, why this is such an advantageous thing to do in your career. The first benefit I'm calling try it before you buy it. There's really two different aspects of this that can be beneficial. And one of the things that I found in my career was that early co-op experience I had as a freshman when I did get placed provided me some experience that influenced my eventual degree choice. If you're a senior in high school and you're applying to an engineering program, they're going to ask you what kind of engineer you want to be. But there are many different specialties within engineering, and you may or may not know what fits you best or what you're going to enjoy the most until you get some experience with it. I mean, there's mechanical, electrical, civil engineers, computer hardware, software engineering, industrial manufacturing, chemical engineering, materials engineering, and that's a very short part of the major list. So a lot of times people may get involved in a program at first because they think that's what they're going to be interested in the most. Then they find something else that really piques their interest and they really enjoy doing. And so in my case, what happened was after my first work experience, I realized that I had chosen an industrial engineering program that didn't really suit my personality. I wanted to be more hands-on, more involved with the direct manufacturing process. So after my first co-op work term, I went back to school and changed my major to manufacturing engineering, which is similar and there's a lot of overlap, but more directly involved in the processes rather than in the financial and labor management aspect that industrial engineering tends to focus on. The other side of the coin is that as you're working through the co-op program and you get more experience, you're going to find that you observe people, the engineers that you're working with around you, there may be skills that they use regularly that you aren't up to speed with yet. So you can use those observed skills to help choose some elective programs at the end of your college curriculum. A really good example I tell people about is this particular class here. So I worked in a factory, highly automated, high volume automotive factory. There was lots of PLC automation controls found on pretty much every piece of equipment we had. And I knew it was very important to understand how that worked, but I didn't know how they worked at all. So one of my electives I chose was a class called Logic Systems for Manufacturing. It was actually an electrical engineering course. And when I first put that to my university advisor, she wasn't sure I was allowed to take that until she checked the program to ensure that manufacturing students could take it. It was a very valuable course. It was all electrical engineers and myself in that room. But it's a skill that I found very useful along the way as I've worked in different experiences that require me to adapt or upgrade automation within factory environments. It's one of those ones where my advisor said she never heard of anybody in her program taking it, but I recognized through my experience as a co-op that was going to be very good for me to have some skills in. There are other classes I took as well, polymer science, because I saw the high use of adhesives and polymers in my prototyping experience as a co-op. I saw the large amount of molded housings we use in electronics, so I took a class in polymer processing or injection molding. In electronics, we use a large amount of ceramic devices, so I made sure I had some experience or at least education in the processes by which those products were made in our ceramics processing class. So I used my co-op experience to kind of direct the classes I took in the 4th and 5th year of my program to make sure it focused on the things I saw the engineers around me using regularly. So the second benefit is what I call don't be a broke college student, right? So college is expensive. When you're at school, it really is important to focus on your studies, especially in difficult programs like engineering. One of the big benefits of the co-op programs is that they pay a wage and include benefits that are offered to all the employees within that organization. I had financial aid packages I used to help pay for my undergraduate experience. In them, I had some college work study available to me. But because I had a co-op sponsor and I was able to collect a paycheck for about 24 weeks out of the year, I only needed to use my college work study benefits during my first semester before I had a co-op sponsor, and during my last semester where I had a relatively low credit load. That's just a little way to put some extra pocket cash in my pocket. For all of the rest of the time, I did not have to work while I was in school because I could focus on my studies and work while I was away from school, gain experience, and collect a paycheck at the same time. This paycheck helped provide for some of those college intangibles. Your books are very expensive. Books is an expense that you don't realize how bad it's going to be until you get there. Living expenses. Every year, I was able to pay my fraternity house bill just with my co-op wages that I saved up over my work terms. So that was very helpful, and it helped alleviate some of the financial stress that's involved in attending college. And finally, everybody likes money, so having a little money in your pocket is good. And you're not going to be paid minimum wage in an engineering co-op program. You won't be paid full engineering wages, but you will get decent money, more than a lot of your friends that are working outside of a co-op program or collecting from them, maybe their side jobs or Uber or whatever it might be. You're going to be collecting a decent paycheck in these kinds of programs that will definitely help alleviate the financial stress of attending college. And then the third benefit is probably what I would consider the most important one of all. I call this Workplace 101. Being involved in a co-op program allows the student to learn about workplace culture and workplace norms. And that's something you're not going to find a course in college or a textbook that's going to teach you how to deal with some of these situations. A big one is employee benefits. You're going to sit down with your HR business partner. They're going to go through all the benefits available to you as an employee. You may not take advantage of all of them now. Health insurance, probably not. You may very well be on your parents' health insurance. But you'll get an idea of when it's time to make that decision, what factors to consider, the information available to you. So this gets you used to and ready to become a full-time employee after you've graduated. Communication skills and norms is something very important. One thing about engineers, we do tend to be introverts naturally. And so sometimes the communication skills aren't our strength. So having that real world experience can be very beneficial. You'll attend meetings, you'll see people give presentations. You may be required to give a small presentation at the end of each semester. So you'll get some practice and some experience in these areas. Email and telephone norms. Email norms are different than social media, Twitter norms are going to be. You have to be more professional, no TTYL, full sentences, full punctuation, grammar will count in professional emails, and telephone norms. It's probably very likely many of you use your telephone to talk to people in current modern worlds. But you will find yourself on the telephone with different people within the organization. So it's a good way to get some practice at an experience and skill within the business world that you may not have right now. And also you'll be forced to engage with new people in your organization. So it'll force you to kind of put yourself out there and understand how you interact with people that may be more experienced than you in an area that you need to engage with as part of your professional responsibilities. In my case, it also taught me a lot about factory life. A factory is a community. And there are lots of factors of factory life that you're not going to find in a textbook. And there are some small things and there are some large things that are important to get experience with. Many people get that first experience after they've graduated and received the degree. People that have co-ops have that experience before they get to the degree and have a leg up on recent college graduates in that way. Something as simple as learning how to send and receive shipments and packages from the factory. When I worked at Ford Electronics, we used to joke that the self-packaging area was the co-op break room because we always found ourselves down there packing something up. I mean, it really is busy work, but it's a way to get you experience and interacting with different organizations or different roles in the factory. You'll be exposed to different various quality management systems depending on what industry you're in. ISO 9001, AS 9100, IATF 16949. That may mean nothing to you right now, but after working in a factory that conforms to one of those quality management systems, you'll have a very good understanding of how we control the quality and procedures within a factory environment. And then on top of that, you'll become more familiar with various roles within the organization itself. You'll interact with design engineers, with manufacturing engineers, with quality and reliability engineers, regardless of what your role tends to be. You'll work with different skilled trades of technicians and mechanics on the production floor. You'll interact with corporate management, plant management, departmental management, engineering managers, production supervisors, and operations personnel, production staff, facilities, people that are required for maintaining the actual facility itself, electrical, mechanical, plumbing, heavy equipment. And you'll learn the different points of view of these different parts of the organizations, how to achieve success with them in different ways. And you're not going to find these kind of skills in any book or any college course anywhere. So you really get this Workplace 101 course over the amount of time you're working within that organization. And that's the benefit for both you and for the company. You get benefits from learning how to be a better full-time employee when you're ready for graduation. And the company gets to observe how you interact with people over the time when you're a co-op. It's almost like it's a long-term job interview. The school I come from, some absurdly high percentage of people actually accept jobs from their co-op sponsor at the end of their co-op program. The rest of them either get a job at a different company or go to grad school. I think we have something like a 0% rate of people that don't graduate with a job or an acceptance to a graduate school out of our undergraduate programs at Kettering University. So hopefully that gave you some idea of some of the benefits of different co-op programs. Encourage you to research those and seek them out when you're seeking out the university you're going to go to for whatever education you choose to pursue, and some ideas on how you can actually go out there and actively participate in the placement program and get yourself placed in a co-op program. So with that, I'm going to pass it on to Robert, who is going to discuss a little bit about the assembly program within CASE.
Very good, Jason. You sold me. How do I sign up for co-op?
Time machine, go back about 30 years and we'll be college students together.
Oh, maybe a little bit longer than that for me. Oh, very good. Yeah. So the co-op you described is kind of geared towards the engineering, kind of the college university path. So some people aren't going through the college university path. We have an assembly program at CASE in San Diego, and that's we're calling it's actually a job, assembly jobs. And along with those jobs, we've developed an apprenticeship program. The apprenticeship program is geared towards bringing people in as entry levels, but instead of taking them the many years to get the experience, we want to get our high potential people and bring them in through an apprenticeship program and get them higher level a little bit faster with more hands-on training, more one-on-one training with a mentor, so that they can learn and develop skills a little bit faster than they would just on the production line in their daily job. So now they're working and paid as a regular job, but somebody is going to focus on them and say, hey, we want to grow you a little faster because we see the potential in you. We hired you in with your potential. We want to get you to the higher levels, become an assembly level 2, assembly level 3, maybe what we call a process owner in the area that's kind of a knowledgeable expert in the area. So we want to go through get you through the learning curve a little bit faster than you might. So that's what we call our apprenticeship program. Let me talk about what that means in the assembly world at CASE here. Our products at CASE are very high tech. We talked about defense electronics. It's very high tech product. They need to work, mission critical stuff that needs to work. So we build products to industry specs, industry standards. Jason talked about quality management systems. So we need to follow a lot of specs. IPC is a leader in some of the industry specs. We follow to some of the IPC specs because everybody else accepts those specs also as being the right standards. And what do I mean by specs? This talks about the quality of a solder joint for electronics. It might talk about the quality of a screw fastener joint. How tight does it have to be? We torque things. We don't just screw things and say, oh, I think it's tight, we go along. Back in my day, a long time ago, a lot of boys in high school, hey, we're going to put our own car stereo in our car, right? We're going to buy some speakers from a speaker store. Radio Shack at the time doesn't exist, and we're going to wire them up and just get a $5 hand soldering iron and do our soldering ourselves. Well, that may or may not have worked because we were just faking it. We didn't really have any training. We just saw what the other guy did, and we put some solder irons together and hope that things made a solder connection, and I turn it on and it works. Well, at Case here, we don't go to that. We have to go to industry standards, IPC specs and like that say, this is what a good quality solder joint looks like. This is what acceptable is. This is what's not acceptable. So that's where our training comes in. We train to standards. We build in a high-tech environment. In Case over here in San Diego, we build in what we're calling a clean room. Clean room environment means we control the temperature of the room, we control the humidity of the room, and we control the particle counts of how much dust is floating out in the area so that we don't get all those particles falling in our electronic assemblies. So that's what we call a clean room environment. So it's a nice environment to work in. If you want to do hands-on work, it's in a clean room. We're wearing clean room smocks. We're going to wear gloves so that we don't get oils and dirt from our skin onto the product, because all of those dirt and oils affect the product. And once again, our product here at Case, it's all mission critical. We have to know that our electronics are going to work for up to 20 or more years. We have to know on the aircraft that when the aircraft pilot is pushing a button to turn something on, it better be working, and not we hope it works and the electronics might have broken or not. So once again, the clean room environment, high proper training that goes with that, delicate product. We don't just slap things together and pass them on. Our production room, our production lines, we call it a mixed, a low volume, maybe medium volume mixed product line. We're not like an automobile factory where they tool up very highly. They put very expensive things into tooling. They build thousands and thousands of product a month. We're not quite at those high volumes. We might build hundreds a month, or even 30s or 50s a month. So what that means is it's more operator hands-on. The operator doesn't just slap things together, push a button, and the tooling makes it perfect. The operator has to be skilled and do some fine hand manipulative work with some skills that they've developed over time to get a proper solder joint, to get a proper wire bond joint. And that's once again where our apprenticeship program comes into place. Is we're going to have master trainers work with the apprentice to show them some of the finer hand technique. How do we, when is it too much? When is it too little bit? How much force? Which direction do I want to come from? That's a lot of the hands-on training that might take years for people to develop unless they're being really coached by a mentor and to show them all the tricks and hand techniques of that. But once again, it's going towards making sure we got high reliability products and built to quality standards. Our environment here, all our products are, we saw the different tiers of the products. We go down to the component level, which is really small. So we're looking at things that are microns, millimeters in size. We attach wires to product that are thinner than the diameter of your hair. We're talking wires that are 1/1000th of an inch in diameter. Your hair is probably about 2 to 3 thousandths in diameter. So wires that are smaller than your hair diameter, we got to install using a machine, and we got to install it to a circuit board. That's microscope. So we've got what's called stereographic microscopes with 2 eyepieces. It gives us a 3D image. The operators are going to work at a workbench, and they're going to look under these microscopes, and they're going to use small little hand tools, little tweezers, and little probes to do this fine handwork assembly. So different from other types of assembly. If you like to do hand type small work, that's good. Some people like to build walls and paint houses and build engines. That's a different type of assembly environment. So you've got big scope stuff. We are very small and delicate in our assembly. Patience critical. We can't be doing very high shaking and moving around, and we're not doing stuff like that. Our assembly jobs are really delicate. Sitting at a workbench, sitting in the clean room environment, once again, we have the tools laid out in front of us. And so we also work in a lean environment. We call the lean environment goes into continuous improvement. We get the operators the tools they need, the parts they need, right within hand reach, so that they're not fumbling around, wasting time looking for tools. They're not fumbling around looking for parts. And I got the wrong things, like people that have their tools in their garage, like me, spread out. Where did I put my tool? Where did I put this? Oh, I got to go find some wood. Where do I carry that? Nope, we want to put the parts with the operator. We want to put the tools with the operator. They've got what they need. They can focus their time on building the product. We have support people that bring them materials, that bring them jobs, so they can focus, once again, focus their time on actually building the product. I'll call it more like a craftsmanship environment, right? So assembly, as I described, it's not just slap things together, it's more of a craftsmanship. Over time, you develop those hand skills. Think of anybody that does fine type work, optics people, sewing, tailors like that, even nails, the people that do the paint the nails and things like that. You develop a skill over time. You get fine hand skills. That's what our assembly programs are geared toward. That's what our assembly operations are like. And once again, the apprenticeship program for that is getting somebody not only the hand skills associated with improving that, but also the knowledge skills to get them. What do these products do? How do I verify good and bad product? What's the inspection techniques that go with that? Making sure I understand what good and bad is, and growing a little faster through the apprenticeship program. And once again, everything we do is striving towards continuous improvement. That's in any high-tech company. They're going to look to, how do I do things better in the future, and strive for the continuous improvement. And IPC, I know, has training on those type of things also. So that's always a good program. That's about all I have as far as the assembly program here. I think we're probably open up to questions now.
Absolutely. So I was trying to get my bar up so I can unmute myself, and I was like throwing my mouse down here and it didn't pop up, but it finally did. I hope everybody can ask questions. There is a Q&A panel, but I got a few sent to us earlier. So students and teachers are very much interested to know what is the difference and or benefits between an apprenticeship and a co-op. So I'm not sure who on Case's team would be able to answer that the best, but that's one of the questions.
But that's a really good question.
Yeah.
And I bet you the differences are pretty subtle. So I'll try to answer it. I don't know if I'm going to get it right, but I'm going to do my best. So an apprenticeship program is generally a situation where you're learning a skill directly from a mentor that has achieved a certain level of expertise in a very specific skill. So you think of things like engine builders in automotive is a good example, where you don't just walk in the first day and build an engine. You learn all the aspects of that from a master that will, or a plumber, or electricians also typically work on these kind of programs, where an apprentice plumber or apprentice electrician will be working directly under a master plumber or electrician to learn those skills. So it's a less formal, more experiential type of education that you get. With a co-op program, it's really, the term co-op implies that there's a cooperative working between the school and the place of employment to ensure that the student learns at the place of employment things that are relevant for the school. But there isn't necessarily a direct curriculum that you're learning as part of a co-op. You just kind of go to work every day and do the work that gets assigned to you and do the work that comes in. And you may walk out of that without any specific direct skill that you've improved that semester or that experience, but you've gained more general knowledge in the workings of the organization around you.
Thank you, Jason. Very thorough as always. Anyone else would like to add, please? Yes.
Yeah, so I think the other thing too is that there's really 3 different types of programs for students to become involved in organizations. There are co-ops, and technically co-ops are, as Jason said, kind of this I guess, coordinated effort between school and an organization to bring that work experience to a student, they typically are a little bit longer in terms of time and commitment. So, for example, we have a co-op program with Drexel University, and that co-op program lasts for 6 months. So students are here for a 6-month period of time, and it gives them a little bit of time to really get their hands dirty on some real, gutsy stuff. And that's nice because our products are not something that you can learn in, 3 weeks or 6 weeks. So the co-op programs tend to last a little bit longer. The apprenticeship programs are, as both Robert and Jason said, are full-time jobs, where you're actually learning skills and doing a development plan to continue to gain experience. And I think in some programs, like in Pennsylvania, we have some part-timers that do that as well in the apprenticeship program. But then there's also just regular internships. So, some of those internships are a little shorter, so maybe 2.5 months during a summer break. And to be honest with you, it really depends upon either the university or the school that you're attending. So with Drexel University, as opposed to what Jason was talking about at Kettering, Drexel has they have 3 semesters every year. So they're able to do, a rotation every 6 months, but they don't get a break at all. The students go, one semester ends on a Friday and it starts on a Monday. And so, if your co-op ends on a Friday and you're on the next co-op, you start that Monday. So time is a big difference in some of the programs. And so I think it helps you as you're going through it, how much of a commitment do you want to make to an organization? What do you want to learn? So these are all the questions that I would start thinking about as you're in your experience. And some of my students go to all 3 of them, and it works very well for them.
Great, thanks, Dave, for answering that. I have a question from Nikita. She wanted to know how can an international student increase chances to get an internship as an engineer while doing and studying towards a bachelor's?
So the difficult thing about an international student at our organization is that they would not qualify for a clearance. And most of our engineering individuals would require a clearance. We do have some positions that do not, but typically not in the engineering realm. You would have to at least be what they call a U.S. person. What I would do, though, is there are organizations outside of CASE that do sponsorships. And I think that one of the things would be helpful is for you to identify, what are those organizations that can help you do that. And your career counselors at either your school or your college should be able to help you find some knowledge about that.
Yeah, I can say in my experience, when I was a freshman, I had 2 different international students in my dorm hall. One of the young men came from the Dominican Republic and another one came from Serbia, Yugoslavia at the time. So in their case, the way they improved their chances of getting a co-op or internship was by applying to and being accepted at a school where this program was a mandatory part of the curriculum. That way, the university has skin in the game to help place those students. And like Deb says, there would be some locations like organizations like ours where it may not be possible or maybe very limited opportunities for international students. But there are other ones where that's wide open and there's no restrictions there at all. And so the university would be able to help and would actually, advocate for you and also be kind of responsible to help you get placed as part of their program if they require you to be involved in that.
Yeah, that's an important tip, and it kind of gives us a segue into some of the other questions, because, if the minimum requirement to actually get an internship, usually you have to be either in a college studying towards an associate or engineering type of degree, right? So high school students interested to getting their hands and their skills kind of advanced. What should they do? And then secondly, on that brink, entering the industry via high school, or then considering going to a tertiary education or post-high school kind of associate or degree. Is there any link between going to a specific school? Like, does it need to be prestigious, or is it just that degree paper kind of work that you need with experience? So I kind of bucketed a couple together. So please go ahead and try and answer some of those for the students.
So let me start with, so in San Diego, as we talked about the assembly positions, our assembly positions do not require the college degrees, engineering degrees, things like that. I think our minimum is high school diplomas. We are able to take assembly people out of high school with a diploma. That's where our apprenticeship program comes in. We can offer the full-time jobs to the right person, and they can follow the apprenticeship program without having to go on to secondary education like the college degrees or like that. And our apprenticeship program is geared towards, once again, getting them through a learning curve a little bit faster than they would on their own, working in the assembly floor and taking a few extra years to gain some of that knowledge and get more skills. Now the other type of positions that Jason mentioned, getting maybe into engineering or management, those are probably more geared towards the college type programs. So I'll leave it at that. But I just want to emphasize there are programs you can come out of high school, like our apprenticeship program, and go into a working job and still get some training by mentors as an apprentice and learn a little bit faster.
Yeah, absolutely. And we also have an apprenticeship program here in the Lansdale site that works exactly the same way. And so I think the only thing we really look at is, if you have a propensity for STEM programs. So did you take, did you take a little more science classes and mathematics when you were in high school versus maybe English and social studies? Those are the kinds of things that are going to be things we look at. And don't negate how important it is to have programs outside of school. So if you're in, an Eagle Scout and you've built, race cars, or you've done, not too many people do ham radio anymore, but, those types of extracurricular activities are things that we look at in terms of, taking a look to see, what kind of person you are as well and what your interests are. And I think all of that leads to a very well-rounded individual that is someone that we look at. I think the other thing to think about, which is so nice about these apprenticeship programs, is remember, we're an organization that also has tuition assistance. And so the nice thing about it is that we can take a person who has interest in furthering their education and fund that further education for them. And that is something that is invaluable in today's world. So remember that, these programs do exist everywhere. So something to think about.
Very, very true. And Deb, while you were talking about like sharing some of the interview tips, like how can you present yourself as this rounded individual, you're interested in this industry, in this field, you have the right electives at school, et cetera, et cetera. So coming from high school, for instance, Robert as well, and Jason, with all the experience you have had in your career, what can a student do out there to gain experience if they're in high school, to kind of showcase? What can they actively be doing to make themselves worthy of a candidate?
From the engineering side, or not just engineering, but the ST and M in STEM, one of the important things there I would recommend that I did was look to see if you can take advanced placement courses as part of your high school curriculum. I took advanced placement calculus and advanced placement physics when I was a high school senior. And so you're actually showing the employers that you're capable of handling college level topics at the high school level of your life. And that's really what the employers look for. They're looking for the quality of the candidate. They're not necessarily looking for just people from certain universities that may be prestigious. They're looking to get good quality candidates regardless of what school you go to, or regardless of whether or not you're going to school or not. Depending on what you're looking for, it's really about the quality of the candidate presented to them then and how well they fit the needs of the organization and how well the organization can fulfill the needs of the candidate in that process.
So I'll add that as Jason mentions, any advanced level courses, even in the assembly positions where a college degree may not be required, advanced math is not required. But if you're able to show that I've done more than the minimum to get by, I've taken an advanced class, I've done more, I've taken the advanced math, even though I'm not going to college for an engineer. But that shows that you're doing more than what's required to just get by. Those are the kind of assembly people we would want to hire into an apprenticeship program, because then it says, here's somebody that wants to learn more and wants to learn more. And that's what we want our apprentices to do. We want to grow them through that learning curve a little faster, rather than somebody being forced, well, if you want to become a level 2 or a level 3, you have to learn all this stuff, and then it takes them time. We want somebody that says, I want to learn whatever you can give me, and then I hope I fit into a higher level job, and that's how that'll work out. So that's a good point that Jason makes. Anything above the minimums and do something more and show that, and then highlight that in an interview. Hey, look what I've done extra. Here's the extracurricular activities that Deb mentioned. All this kind of extra stuff.
And I think from maybe the softer side of the skill sets, some of the things from an HR perspective that we look at in candidates that are looking at entry-level positions, don't negate when I talk about the extracurricular activities, your sports that you take and your successes within that area. If you do musical activities or any other activities that show, the kind of interests that you have, and, things that show what you have volunteered for. Perhaps you did some volunteer work when you were in high school. These are all things that allow you to present yourself as a more well-rounded individual, and also shows your need to be successful. And when we look at individuals, we look at people that want to succeed, that want to grow and develop. And if we see that in someone in the high school level, as you get closer to, working full time, chances are you're going to carry that into your working career. And so think about those things. And then the last bit of advice that I would give you is, don't be afraid to practice, because interviewing is not a skill that people learn, that comes intuitively. Most people don't like to sit down and say, oh, I think today I'll talk about myself. So, it's really important that, although it might seem a little ridiculous, if you don't have a mirror, sit at the bathroom and look at the mirror when you're brushing your teeth and say, today I'm going to practice how I'm going to answer this question. There is a lot of information out there on the internet about, top 10 questions that people ask, students, or, and look at them and practice those questions. Get your parents maybe to kind of do mock interviews with you, because I would say the number one thing that shows a successful interview is someone who can communicate and articulate well. And if you can get past that, that allows you to have that foot in the door that says, I can represent myself, and I can represent myself well. And that it's a very important skill to have.
So these mock interviews that Deb's talking about, in front of a mirror, in front of your parents, even film yourself, right? Film yourself and watch your video and say, oh, I don't like the way I look there. Oh, I was too quiet there. Oh, maybe I need to stand up straighter there, and think about that. You can see yourself nowadays. That's so easy nowadays. Everybody does that. Years ago, that wasn't so easy, but now it's very common.
Very true, because I've learned my courses at university that you communicate verbally, but also nonverbal cues. And so the way you also present yourself is very important. And I think also when you are in an interview, you always want to put your best foot forward, but sometimes you can not necessarily be scared of how you have failed and solved a problem, because that will also show part of your character. You are, not going to end until a task is complete. So I think there's a lot of things that you can do to showcase failures into a positive. Make sure that your resume also doesn't have any typos. Have friends and people like proofread it, because that is the first impression. And then if you put that black ink on that white paper, make sure that you can truly talk about all of the things that's on there, right? So always be trustworthy. And on that note, with kind of experiences and the coursework, Keith wanted to know, let's say we put it on a weighing scale. Is coursework or relevant work experience more important for your resume when applying for an engineering internship?
That was a big point that you mentioned about, if you put it on your resume, make sure you can talk about it, because that will show very well in a resume. If the interviewing manager asks you a question about that statement that's on the resume and you're kind of fumbling through, chances are they ask it, they might know about it very well. And then if you're fumbling your answer for that, you're going to get caught. So that was a very big point you made here.
Yeah, to Keith's question, from my experience in my personal co-op internship that I had as an undergraduate, I had no relevant work experience and I had no relevant coursework. I was a first semester freshman that was being interviewed at Ford. So I was still taking, basic calculus, physics, chemistry, your basic science classes, nothing in engineering yet. Had never worked in the engineering field, didn't know what solder was, so when people are assessing candidates for these kind of experiences, internship and co-ops, there's not a lot of expectation that you have the background yet, because that's the purpose of the position you're trying to achieve, is to get the experience. And life's one of life's big catch-22s is you can't get the job till you have experience, but you can't have experience till you get the job. Well, internships and co-ops are supposed to break that chain by getting you into that cycle and getting you the experience before you actually have some to show. Then when you graduate, now you have the experience to show, and you can cycle through I have experience, I got the job, that experience gets me the next job, etc.
That makes total sense. And just for the students to know about CASE, is there a specific time when students should be actively looking to apply for an internship, a co-op, or an apprenticeship program? How would you guide them? Is it like during the summer, or is it fall? I have no idea. Please help.
Well, I would say this, is that if it's a, quote, summer internship, then we typically will start advertising as early as October and November in the year prior to the summer. But some of those positions, so for example, I have 2 internships open in manufacturing engineering right now. And so we are actively recruiting for those positions. So what I would say is, for summer internship, start early, start October, November-ish, and keep your eyes open for those. The co-op positions that we have open are actually in conjunction with the university. So we go based upon their schedule. They tell us when we're going to hire them and what's going to happen. So, and all that advertising is done through the school. And Robert, I don't know about what happens in San Diego. Our apprenticeship programs are open almost year round, I think. So how does that work in San Diego?
Yeah, ours is going to be based on our assembly needs at the time of how much we're hiring for the assembly areas. A couple of years ago, we were hiring quite often, and so we would have probably had this open at all the time. For the past few months, we haven't been hiring people. Our staff matches our workload right now. I think we are expecting in San Diego to probably bring in more people third quarter of the year. So I'm guessing that would be the appropriate time for us in San Diego. It's based on our needs for the production people when we need to bring up our staff.
Fantastic. We are basically at time and running out. We were thinking of maybe one more question. Are there any differences?
too. A couple questions here.
Are there any differences in procedures for job applications and co-ops or internships? Or is it the same process?
The process is slightly different, although the hiring process is similar. So getting in, applying for the internship would still go through the same process. We'll post the position, you would apply, you go through an interview process, you then have to go through background checks and the whole process that we do for hiring an individual. I think what's different is maybe the access to the organization is slightly different.
Fantastic. Nikita was very active. Jason, thank you for typing an answer to her. She is very interested in learning more about these opportunities. So where can the students go to find more information on your website? Do they just visit CASE? Is there a specific tab? What would be the best?
So for all of our positions, you want to go to CAES.com, CAES.com. There is a careers section, so you can actually type in careers at CAES.com. When you get to the career section, you have the opportunity to look at all jobs. You can sort by locations, you can sort by functionalities. So if you wanted to look at everything in operations or everything in engineering, you can do that. And of course, that's probably the best bet to keep your eye on, what those positions are.
Excellent. Well, thank you, Dave, Robert, Jason, as well as Andrea. Thank you for your time. Thank you for sharing insights about your personal journeys, who you are and what you do. I am 100% sure that these students and teachers who attended it, thank you to each one of you for being here. If there's any additional questions, you are more than welcome to send it to the IPC Education Foundation, and we will definitely, redirect it to the wonderful panelists here. We hope that each one of you have a wonderful rest of your Friday, have a wonderful weekend, and please be on the lookout for great opportunities CASE will be putting out on their website for each one of you. So thank you so much. It was wonderful to meet today. Have a great day.
Thank you for having us.
Thank you.
Yep, thank you.
Thank you.